Hello, my name is John Kelly. I'm a professor of urology here at University College London. And I'm joined by Ronnie Stafford, who is a senior data scientist working in machine learning at UCL.
Hi, everyone.
We're going to talk today about an application which will have implications for training, but which we have developed primarily to collect outcome data, to monitor patients after surgery. The program is called HALO, Home and Locally Observed, the concept that we can watch patients at home using wearable sensor devices and observe for problems arising after surgery. Over 300 million major surgical procedures are performed per year. The readmission rate is as high as 20%. And on the graph here, we can see that readmissions, for example, from infection, failure to thrive, may be largely preventable. We believe that wearable sensors present the acquisition of data, which will be a new omic, just in the way that genomics or metabolomics or proteomics has been in the past. Indeed, if we look at systematic reviews, which we performed back in 2015, the number of studies then and now is strikingly different. There's an exponential increase. Our interest in this area came through a randomized controlled trial, which we performed called IROC, comparing open to robotic cystectomy. In IROC, we applied fitness trackers to patients for 7 days at a time at variable points along their care pathway. What we find from the IROC study is that the fitness tracker data bore no correlation to, for example, patient-related outcome measures. It may therefore be that this type of data presents a whole new independent area of examining patient well-being. In some of our analyses, we find that data from fitness trackers, such as maximal step counts, were independently predictive of outcomes defined as Clavien-Dindino complications grade 3 or higher. So IROC is showing us how we might apply fitness trackers or sensors in the future. But what we also learned was that over a 30-day period, over 8,000 data points are collected for each patient. And clearly, this type of analysis beyond simple rule application requires machine learning. To this end, a project team was established with the Centre for AI at University College London, with a remit to build a platform for real-time acquisition and interrogation of sensor data. In simplistic terms, a patient is discharged from hospital with a wearable device. That device interfaces and is uploaded through the cloud to a patient and physician-facing dashboard. However, for real-time analysis, we have machine learning algorithms that can detect and identify changes in healthcare status. I'm going to ask Ronnie just to describe the platform in greater detail. Ronnie.
Yeah, thanks, John. So if you look to the top left of the slide, you can see that typically every patient is given an iPhone Apple Watch pair. We are moving to Android eventually. The Apple Health Kit is Apple's own proprietary software, which extracts heart rate and step counts from and other time series data and health kit data from the wearable device and stores it in the mobile device. We install our application on a patient's mobile device, and it periodically extracts this health kit data and sends it to our backend server, which we host at UCL. Also, our app on a daily basis prompts patients to fill out their PROM questionnaire answers, and this is also sent back to our server. The backend server you can see at the bottom. As I said before, it's hosted on our own UCL server. The web app is designed like any other modern web app, its architecture. It receives data from all of our devices from across the internet, does a bit of processing, and stores it in our own database, which is also hosted at UCL. The architecture is scalable so that we can cater for large volumes of traffic if need be. We're currently developing a data science platform for patient analytics, ML predictive tools, and anomaly detection in the back end. There's also an additional facility for researchers and clinicians to log into the web app from their web browser across the internet to view any patient's health kit and PROM data. So if we go to the next slide, these are screenshots of the actual app that is installed on a patient's mobile device. The left screen demonstrates a patient onboarding screen where a clinician leads a patient through the onboarding process, specifies the study and study site, and the commencement of the monitoring. The middle screen is typically the main status screen of the app, which displays the status of when the last data dump to our backend server occurred, and also prompts the patient to fill out their PROM questionnaires. Finally, the right-hand screen is an example of what it looks like for a patient to specify a PROM question and answer.
Thanks, Ronnie. Thank you. So we have conducted various studies. I'm just going to introduce one of our early studies in which we used a variable number of medical devices which were seamlessly connected to the framework which Ronnie describes. And this is an example of two patients, patient A on the top, patient B below. Patient A is sitting with a heart rate that sits below a danger zone, the red highlighted area, and actually recovery is quite smooth. Patient B has a heart rate which for a period of time rises into the red zone or danger area, and during this time the patient is not moving. So this is a tachycardia at rest. This patient ultimately 2 days later was admitted to hospital with sepsis. The framework had the ability to upload the data. The analysis had the ability, or the analysis then highlighted the problem, and this could have been an earlier, more prompt diagnosis. So how will this application have a role in surgical training? Well, on the one hand, we found this application to be of use in a randomized controlled trial looking at 2 different surgical technologies. And obviously, we will continue to use this as a research tool for this type of application. However, for many surgeons, for us as surgeons, key performance indicators such as mortality and morbidity are generally not adjusted for case mix. We apply them in a very crude setting, and it's very difficult to individualize outcomes on that basis. Further, we now can show that we can collect data seamlessly and present it to a dashboard for an individual surgeon to monitor their performance against other KPIs. Currently, this does not exist at this time. So we feel that this is an exciting tool. Thank you for listening, and we look forward to any questions.